Section 5.2 Interactive Assignment Objective 2. The data in the following table show the association between cigar smoking and death from cancer for 131,630 men. Note, current cigar smoker means cigar smoker at time of death. So here is the table. We have never smoked cigars, former cigar smoker, and current cigar smoker, which are your rows. In the columns, died from cancer and did not die from cancer. The questions that we're asking are, Part A, if an individual is randomly selected from the study, what is the probability that he died from cancer? Part B, if an individual is randomly selected from the study, what is the probability that he was a current cigar smoker? Again, in Part C, if an individual is randomly selected from the study, what is the probability that he died from cancer and was a current cigar smoker? And then Part D, if an individual is randomly selected from this study, what is the probability that he died from cancer or was a current cigar smoker? So I loaded this information in here. Okay, so the data in the following table show the following. Now the first thing we want to do is we need to find the totals. Okay, so how do we find the totals? We need to add up the column here. So 582 plus 59 plus 149 gives us 790. Okay, so that's going to give us a total for the column from died from cancer. The second column is did not die from cancer, and we're going to add these numbers up. When we add these numbers up, we get a total of 130,840. Okay, likewise, we're going to add up our rows. So we want to add up the row where it represents never smoked cigars. We're going to add these numbers, 582 plus 120,318, to give us 120,900. Likewise, former cigar smoker, adding these two items up, gives us 5,146. And then the last one, current cigar smoker, we're going to add those together to get 5,584. Now, again, it says here that the total should match here with this number up here. So we can see that the total is going to represent the following. It's going to represent the 131,630 men. So there is the total. Okay. Now, the first question says, if an individual is randomly selected from the study, what is the probability that he died from cancer? So the event is going to be called died from cancer because that's what we're looking for. We're looking for the event of when he died from cancer. So that's the probability of E. Okay. So the probability of that event E, okay, is the number of times or the number of outcomes where they died from cancer. Okay, so what is the total amount? Well, the total amount that died from cancer is the following. When we add these all up, the total is 790. And then we're dividing it by the number in the entire sample, which is 131,630. We divide those numbers, we get 0.0060. Rounding it to 3 decimal places gives us 0.006. So, putting in our answer, for part A, we get the following. The probability of died from cancer for part A is 0.006. Okay, next. In part B, it says, if an individual is randomly selected from this study, what is the probability that he was a current cigar smoker? Okay, so the event is a current cigar smoker. Okay, so we want to find the probability of the current cigar smoker. So we got to find the number of outcomes where we see a current cigar smoker. Well, here is the current cigar smoker. It is a row. So when we add up those rows, we get a total of 5,584, which represent the total of current cigar smoker. So that's what we have in our numerator. In the denominator, we're dividing it by the total in the sample size, which is 131,630. When we divide that, we get a decimal of 0.0424, which rounds to 0.042. And so let's take a look at the next result. So the probability of a current cigar smoker is equal to 0.042. Okay, next. what we want to do is, if an individual is randomly selected from the study, what is the probability that he died from cancer and was a current cigar smoker? Okay, now the word "and" means intersection. Where do they intersect? So what it's saying here is that we have an event where someone has died from cancer and is a current cigar smoker. Okay, so that means we want to find the probability of someone who died from cancer and is a current cigar smoker. So we got to find the number of outcomes of died from cancer and a current cigar smoker. So what that means is we need to look at the column that represents the died from cancer. So we're going to go ahead and draw a line through that. Okay, and then we're going to look at the row where it says current cigar smoker. So we're going to draw a line through that. Now, where do they intersect? So the word "and" means where do they intersect? So they intersect at what value? So remember, the "and" tells us where they intersect. So they intersect at what? 149. And then we're dividing it by the total in the sample size, which is 131,630. So dividing those numbers gives us 0.011, which rounding it to 3 decimal places is 0.001. So for part C, we can see that a person that died from cancer and a current cigar smoker is 0.001. Okay, now the last one that we want to do is the following. It says, if an individual is randomly selected from this study, what is the probability that he died from cancer or was a current cigar smoker? Okay, now in this case, we're going to use the general addition rule to find the probability, because the rule states that for any two events, E and F, the probability of E or F is equal to the probability of E plus the probability of F minus the probability of E and F. Now remember, this means intersection. That means that this is going to be repeated twice into this. So that means you have to subtract one of those. Okay, so we're going to define our events. We're going to say that E represents died from cancer, and the event F is current cigar smoker. Okay, so what does our formula look like? It says the probability of E or F is equal to the probability of E plus the probability of F plus the probability of E and F. So we're going to say the probability of E, okay, plus the probability of F plus the probability of E and F. Okay, now to find the probability of E, it's going to be the probability or the number of outcomes of event E, meaning the number of outcomes that a person died from cancer, in this case a male, divided by the total in the sample size. So what do we know? We know that, okay, how many have died from cancer? Well, that means everything in here represents how many has died from cancer. So that means in our first fraction, we have 790 divided by the total. Okay? And then what we're going to do is now find the probability of a current cigar smoker. So the number of outcomes that are a current cigar smoker are the following. So if we look at that row, right, we can see that the value of 5,584 is going to be divided by the total in the sample size. Okay, now we got to subtract the number of outcomes where we died from cancer and is a current cigar smoker. Okay, so that means where do they intersect? Well, they intersect right here, which is at 149. So we can't include it. That means we've included in this column, we've included in this row, and that's why we need to subtract that. So we're going to subtract that and get that amount. Now all we got to do is go back and look at what we found. Okay, well, what do we get for 790 divided by 131,630? Well, if you notice here, we got this answer, 0.006. Okay, so it was 0.006. You go ahead and delete that and then highlight it with the yellow there. So therefore, we got 0.006. So just use your results from the previous answer. And then the second one, we got the probability of a current cigar smoker, which was 0.042. Okay, and then the last probability that we got was the probability of died from cancer and current cigar smoker, which was the intersection, which was 0.01. So if we take 0.006 plus 0.042 minus 0.001, then we get 0.047. So therefore, we would get the following: 0.047 for part D.